So we're going to be going through the practice problems for lesson 8. And we've been talking about position, speed, and direction. So the first thing that we have here is a number line can represent positions that are north and south. North and south. And I know that we've talked about these directions, north and south, in other lessons. So let's keep that in mind. And decide whether you want it to be positive positions to the north or the south. And we already know the answer to that. It should be, of course, north is positive and south is negative. Because technically, north is up and south is down. So there's our positive and our negative. It doesn't really make sense much any other way. Okay, so we, what else do they tell us? North or south of the truck stop. So that tells us a lot about where the truck stop should be. So if we create a number line here, and in the middle of our number line is 0, and I know that positive goes to the right and negative goes to the left. So 0, our 0 spot, of course, is going to be the truck stop itself, because both things are being compared to where the truck stop is. So our truck stop is our 0. 5 miles north. So north is in our positive direction. So 1, 2, 3, 4, 5. 5 miles north. We get 3.5 miles south. So it's 1, 2, 3, 4, 5. Let's just make sure that we're all clear here. And then, of course, it's -5 because it's going in the opposite direction of our positive. So that makes it negative. We're looking for -3.5. So that would mean that we would go to 1, 2, 3, all negatives. Those are meant to be negatives. And then this, of course, would be my -4. So -3.5 would need to be right in the middle of it, right here. So it's -3.5 miles south. There we go. Next. How could you distinguish between traveling west at 5 miles per hour and traveling east at 5 miles per hour without using the words east and west? Well, here we go again. West is going to be negative, and east is going to be positive. 4 people are cycling. They each start at the same point. We'll have 0 be their starting point. Plot their finish points after 5 seconds of cycling on a number line. Okay, so I can draw my number line. I can go ahead and do that. And I know that 0 is where they're all going to start. And the first thing I need to do is, of course, figure out how far they're going to go, because we're looking at how far they're going to go in 5 seconds. So these are simple multiplication problems. Lynn is cycling 5 meters per second, so that's 5 meters times 5 seconds, and that would give us positive 25. Next, Diego is cycling -4 meters for 5 seconds. 4 times 5, of course, is 20. I count 1 negative, so that's -20. Elena cycles 3 meters per second, so that's 3 seconds. 3 meters times 5 seconds, a simple multiplication problem there, is 15. Of course, it's positive. And then Noah cycles -6 meters per second. I'll multiply that times 5. 6 times 5 is 30. There's only one negative, so that's -30. So it looks like, based on my answers of 25, 20, 15, and 30, that I should be setting up my number line by 5s. So we'll say this is 5, 10, 15, 20, 25, 30. So this is -5, -10, -15, -20, -25, -30. Okay, so we've got Lynn cycling 5 meters per second. That puts Lynn at +25, which is right here. I'm going to label that as Lynn. Next, we've got Diego, ended up at -20. So that would be right here for Diego. Remember, those counting, we always start at 0 and head down. So the further we are to the left, the lower that number. Next, we have Elena at 3 meters per second, ended up at 15, which is in the middle of 10 and 20. That's Elena. And then finally, we have Noah. -6 for 5 seconds gave us -30, which is, of course, here, and that is Noah. Next, find the value of each expression. Okay. We've got a few things going on here. We've got positives and negatives and decimals and fractions, all sorts of fun things to do. Okay, so this is a simple addition problem, but I've got the signs are different, find the difference. So that, of course, means I find the absolute value of both of these numbers. The absolute value of 16.2 is 16.2. Remember, absolute value is a distance. There's a point there, 16.2. Finding the difference, I'm going to put a subtraction sign in here. -8.4 is 8.4 meters. I don't know why I said meters. I decided they're meters. 8.4 units from 0. So now I'm simply going to be subtracting these two. So whenever I add or subtract decimals, I always make sure that I've stacked my decimals on top of each other, otherwise they won't work at all. Now the first thing I should notice here is that I can't take 4 away from 2, so I need to borrow from the 6. That becomes 5. This becomes 12. 12 minus 4 is 8. Drop down that decimal. And then we've got 15 minus 8 is 7. And then I go back and I look at the number with the largest absolute value. That, of course, would be 16.2. The sign of 16.2 is positive, so the answer is positive 7.8. Next one, I'm going to go down here to the next one's a decimal. And I've got the signs are the same, find the sum. So, again, when I, add and subtract decimals, I'm going to have to stack those decimals right on top of each other. Like, but Mrs. De Silva, this one doesn't have a decimal. Oh, it's always at the end, just like the period at the end of a sentence. And I'm going to add these together. So I'm going to give myself a placeholder for that 2. 2 plus 0 is 2. Drop down the decimal. 9 plus 7 is 16. And then because they're the same, and you'll notice they are both negative, therefore your answer has to be negative. So the next one is 16.2. Okay, next. 2/5 minus 3/5. Okay, well, I love eating apples and avocados. A lot of this is already done for us. You don't need improper fractions because it's already done. The least common multiple, of course, is 5, already given. So that means nothing really has to change when we go to the next one of 2/5. minus 3/5. Now, of course, I ignore the denominators for now and go right up here to add or subtract. So this is 2 minus 3. Now, we really should stay, change, and cha-cha-cha, but I just want you to think about this one because it should be fairly obvious that if you've got 2 and you take away 3, that leaves you with -1. When you're in the hole, you owe 1, whatever it is. So then we take the two numbers that we have as our numerator and our denominator, and the answer is -1/5. Okay, for our next one, this is probably the most complicated of all of these, although it shouldn't be all that much complicated. So I'm on my I section of I love eating apples and avocados. So I have to change these, first of all, to improper fractions. So 8 times 4 is 32, plus 3 more is 35. So I've got -35/8 minus, I'm going to have a negative here. That negative should have gone on the inside. There we go. Okay, -1 1/4. So 1 times 4 is 4, plus 1 more is 5. So it's -5/4. Okay, so next, what in the world happened there? That's craziness. Oh, is that... Oh, for goodness sake. I know exactly what that was. That was my feeble attempt at a parenthesis. And now I'm doing all sorts of crazy things here. Let me know if you saw that part. Okay, let's try that again. This is supposed to be a parenthesis, and that's why it confused me when I saw it. Okay, so over here, we're doing our least common multiple. And our least common multiple of 8 and 4 is, of course, going to be 8, because both of them are gazintas of 8, and 8 is the larger of the two. So I know when I come down to the next part here that my fractions need to both have 8 in the center, and it is a subtraction problem. So I've got my 8s already set up and waiting for me. So the next thing we have is we look at how did we get from 8 to 8. Well, that's exactly the same. So it's -35, hasn't changed. I'm actually going to start writing up here -35 minus, how do I get from 4 to 8? Well, that's times 2. I have -10 here. Right? Sure is. Okay, so it's -35 minus -10. Well, if you think about it, if I owe $35, that's -10, and then I'm taking away 10 of those negatives, I'm left with -25. So I'm going to stop right there with that as far as making it -25, because that's really the only thing that makes sense at this point. And then I have to take my information and make it into my final answer, so that's going to be -25/8. And yes, you can go ahead and leave it like that, or you can reduce it. It becomes -3 1/8 if you do. For each equation, we're going to write 2 more equations using the same numbers that express the same exact relationship. Oh, this is easy. We did this in the beginning of the chapter. So the first thing I can do for all of these, of course, is to switch the order of those first 2 numbers. So I've got 3. I just said switch the numbers. So what I meant was 2 plus 3 equals 5. 3.4 plus 7.1 equals 10.5. I am sure that you could have done this back when you were in first grade, because it really is that obvious. Until we get to this one. I've got 15 minus 8. 15 taking away 8. So in tradition with the rest of them, the first thing I need to do before I can switch things up, because they were addition problems, is to change my subtraction problem to an addition problem. So I would have 15, stay, change, change, cha-cha-cha. So it's stay, change, change. Oops. So I change it to an addition problem, and that positive 8 becomes negative 8. So now that it's like that, I can use it to change it, so it'll now say negative 8 plus 15 equals 7. Which we already knew that. Okay. This one, if we reverse the order, we've got 9/5 plus 3/2 equals 33/10. So that is for sure the easiest and most obvious way to change these equations. But what I'm going to do for this, the next part here, is I'm actually going to take this and move one from the other side. You should know by now the way that we get rid of one on the other side, we have to subtract it on both sides to keep it evenly balanced. So therefore, I could have 2 equals 5 minus 3, or I could have 3 equals 5 minus 2. Sorry, I lost track for a moment there. Okay, next. Again, we just have to, be strategic about this. We know that either one of these can be taken away from the 1050 or 10.5. So I would therefore very simply make that 3.4 equals 10.5 minus 7.1. Or I could have done it with 3.4 instead. So that would have given me over here 7.1 equals 10.5 7.1 equals 10.5 minus 3.4. Okay, hopefully you're getting the hang of this, because it really isn't that hard. If I reverse either one of these out, so in other words, I could have negative 8 equals 7 minus 15. I could then, of course, take these and reverse their order, but I have to make sure that I have that minus 15 there. So it'd be negative 8 equals negative 15 plus 7. I know that that looks a little funny, but that's really just because you're not used to looking at it like that. Okay, and this last one here, if I move either one of them over, I could be left with 9/5 equals 33/10 minus 3/2. Okay, if you don't see your answer here and you're not sure if it's right or wrong, just come and ask me. I'm happy to help.